For centuries, the compass has been an indispensable tool for navigation, guiding explorers and adventurers across vast oceans and uncharted lands. But have you ever stopped to wonder what invisible force directs its needle northward? The answer lies in one of Earth's most remarkable features, its magnetic field. This invisible shield, generated deep within our planet's core, extends far out into space, creating a magnetosphere that protects us from harmful solar radiation. Its influence is not limited to inanimate objects like compass needles. Many animals, particularly migratory birds, possess an internal compass that allows them to navigate with astonishing precision over thousands of miles. How do these feathered navigators accomplish such feats? Scientists believe they have specialized cells that contain tiny magnetic crystals, acting like miniature compasses. These crystals align with Earth's magnetic field lines, providing the birds with a sense of direction. It's a testament to the power and influence of this invisible force that shapes our world. But the magnetic field is more than just a navigational aid. It is a fundamental aspect of our planet's existence, influencing everything from auroras to the very air we breathe. To understand Earth's magnetic field, we must journey to the heart of our planet, where a fiery dance of molten iron and nickel is constantly taking place. This molten outer core, with temperatures exceeding 5,000 degrees Celsius, is in constant motion. This motion is driven by the Earth's rotation and the convection of heat from the even hotter inner core. As the molten iron moves, it creates electric currents, which in turn generate magnetic fields. This process is known as the geodynamo. Think of it like a giant self-sustaining dynamo. The Earth's rotation keeps the molten iron churning, and the electric currents generated by this motion produce the magnetic field that surrounds our planet. It's a complex and powerful system, and it's the reason we have a magnetic field that protects us from the harshest radiation of the sun. Without this magnetic shield, life on Earth as we know it would be impossible. The sun, our life-giving star, also unleashes a constant stream of charged particles known as the solar wind. This solar wind would bombard our planet were it not for Earth's magnetic field acting as a shield. The magnetic field deflects most of these charged particles, protecting us from harmful radiation. Imagine a giant umbrella shielding us from a downpour. That's essentially what our magnetic field does against the solar wind. This protection is crucial for life on Earth, as prolonged exposure to solar radiation can be detrimental to living organisms, including humans. But the magnetic field's influence doesn't stop there. It's also instrumental in navigation. Compasses, relying on the magnetic field's direction, have been guiding us for centuries. Even today, with advanced GPS technology, understanding the magnetic field is vital for accurate navigation, particularly in aviation and maritime operations. Contrary to popular belief, Earth's magnetic field is not static. It's dynamic and constantly changing. One of the most dramatic manifestations of this dynamism is the movement of the magnetic poles. Unlike the geographic poles, which remain fixed, the magnetic north and south poles wander over time. Scientists believe this movement is caused by changes in the flow of molten iron in the Earth's outer core. In fact, the magnetic North Pole has been moving at an unusually rapid pace in recent decades, currently drifting towards Siberia. Another captivating phenomenon linked to the magnetic field is the aurora borealis and aurora australis, also known as the northern and southern lights. These celestial displays of vibrant colors dancing across the sky occur when charged particles from the solar wind are guided by Earth's magnetic field lines towards the poles. As these particles collide with atoms in the upper atmosphere, they excite them, causing them to emit light, resulting in the mesmerizing auroral displays. Section 5. Echoes in Stone, Paleomagnetism and the Tale of Magnetic Reversals. The Earth's magnetic field leaves its mark not just in the sky, but also within the very rocks beneath our feet. Paleomagnetism, the study of Earth's ancient magnetic field, provides us with a fascinating glimpse into our planet's magnetic past. As molten lava cools and solidifies into rock, iron-rich minerals within the rock align themselves with the direction of Earth's magnetic field at that time, like tiny compass needles frozen in place. By studying these ancient rocks, scientists can reconstruct the history of Earth's magnetic field over millions of years. One of the most astounding discoveries made through paleomagnetism is that Earth's magnetic field has reversed its polarity numerous times throughout its history. During a magnetic reversal, the magnetic north and south poles essentially switch places. These reversals are not predictable events. They occur at irregular intervals, averaging about every 200,000 years. The last reversal occurred approximately 780,000 years ago. Section 6. An anomaly in the Atlantic, a weakening shield and its implications. While the overall strength of Earth's magnetic field fluctuates over time, scientists have observed a particularly intriguing phenomenon in recent decades: the South Atlantic anomaly. This region, spanning a vast area over South America and the South Atlantic Ocean, exhibits a significantly weaker magnetic field compared to other parts of the globe. The weakened magnetic field in this region has implications for satellites and spacecraft orbiting Earth. These spacecraft are more vulnerable to damage from solar radiation when passing through the South Atlantic anomaly. Scientists are actively monitoring this anomaly to understand its cause and potential consequences. Some theories suggest that it could be a precursor to a future magnetic field reversal, but further research is needed to confirm this. The South Atlantic anomaly serves as a reminder that Earth's magnetic field is not static, and that changes in its behavior can have practical implications for our technological infrastructure. Section 7. Unveiling the invisible, probing Earth's magnetic field from space and Earth. Studying Earth's magnetic field requires a multifaceted approach, combining observations from space with measurements taken on the ground. Satellites equipped with sensitive magnetometers play a crucial role in mapping the global magnetic field and monitoring its changes over time. These space-based observatories provide a global perspective, allowing scientists to track the movement of the magnetic poles, measure the strength of the field, and study phenomena like the South Atlantic anomaly. On the ground, networks of magnetometers are strategically positioned around the world to provide continuous measurements of the magnetic field at specific locations. These ground-based observations complement the data collected from space, providing a more detailed and localized view of the magnetic field's behavior. By combining data from both space and ground-based instruments, scientists can create comprehensive models of Earth's magnetic field, track its changes, and gain a deeper understanding of its complexities. Section 8. Magnetic insights from mineral discoveries to space weather forecasts. Understanding Earth's magnetic field is not just an academic pursuit, it has practical applications in various fields. One such application is mineral exploration. Magnetic surveys, conducted from the air or on the ground, can help identify deposits of iron ore and other magnetic minerals. By mapping variations in the magnetic field caused by these deposits, geologists can pinpoint potential areas for mining. Another crucial application is space weather forecasting. As we become increasingly reliant on technology, understanding and predicting space weather events, such as solar flares and coronal mass ejections, becomes paramount. These events can disrupt radio communications, GPS navigation, and even power grids. By monitoring the sun's activity and Earth's magnetic field, scientists can issue warnings and forecasts, allowing us to take measures to mitigate the potential impact of space weather events on our technological infrastructure. Section 9. Myth versus reality, debunking magnetic misconceptions about human health. The invisible nature of Earth's magnetic field has led to various myths and misconceptions about its impact on human health. Some claim that magnetic bracelets can alleviate pain, or that exposure to electromagnetic fields from power lines causes cancer. However, there is no scientific evidence to support these claims. The magnetic fields produced by these devices and sources are far too weak to have any significant effect on the human body. While it's true that some animals, like migratory birds, use Earth's magnetic field for navigation, humans do not possess this ability. Our bodies are not sensitive enough to detect or be influenced by the Earth's magnetic field in any meaningful way. It's essential to rely on credible scientific sources and avoid misinformation when considering the impact of magnetic fields on human health. Section 10. Our magnetic legacy, a force shaping life and a future to safeguard. Earth's magnetic field is more than just an invisible shield. It's a fundamental force that has shaped life on our planet for billions of years. Its protective embrace has allowed life to flourish, shielding us from the harsh radiation of space. It has guided explorers and continues to play a vital role in navigation today. As we delve deeper into the mysteries of the magnetic field, we gain a greater appreciation for its complexity and its profound impact on our planet and our lives. However, challenges lie ahead. The South Atlantic anomaly, the weakening magnetic field, and the possibility of a future magnetic reversal are all reminders that our magnetic shield is not invincible. Continued research, monitoring, and a deeper understanding of the magnetic field are crucial for safeguarding our planet and our technological infrastructure from the potential impacts of its changes. By unraveling the secrets of Earth's magnetic mysteries, we not only expand our knowledge of our planet, but also ensure a safer and more sustainable future for generations to come.